Hello students, in the last session we have studied global variables in Python. In today's session we will discuss recursion in Python. So let's start. Recursion or a recursive function is function that calls itself. It is called as a recursive function. So a recursive function is function that calls itself again and again. So this method is used when certain problem is defined in terms of itself. Now one thing to remember, not all problems can be solved in a recursive manner. So there are some problems, yes, which can be defined in terms of recursion, and those problems can be solved in a recursive way. Recursive functions allow programmers to write efficient programs using minimal amount of code. Now one advantage of using recursion is that the line of code will be minimal in case of recursion. Now there is a downside of the recursion also. So the downside is that they can cause infinite loop and other unexpected results if not written properly. So while writing the recursive function, we need to take utmost care while defining the conditions, the stopping conditions of the recursive function. Otherwise it may cause infinite loop which will not end. Okay, so to understand the recursive function, let us look at one simple example. Okay, so this is a recursive factorial function. So this function can be used to calculate factorial of a number in a recursive way. You might have studied an iterative way of calculating the factorial, and this program simply explains how factorial can be calculated by using iterative way. So look at the program here. We have a function definition, that is recur factorial, which has some statements. I'll come back to this factorial function. Before that we will go through the other part of the code. So this is the code inside the function. So up till here we have our function definition, and from here we have the actual programming code. So the first statement in the program here, it is reading a number from a user. So num is equals to int input, enter a number. As you know, in Python input function, it is used to read a number from a console, and that number we are converting it into integer and we are storing it in num. Then we are checking if whatever number entered by the user, if it is less than 0. If user say enters a number that is -1, so which is less than 0, in that case we are displaying a message saying sorry, factorial does not exist for negative numbers. So an error message we are displaying if he enters a number less than 0. And we have a second condition. If he hasn't entered a number less than 0, then we are checking if he has entered a number equals to 0. If he has entered a number say 0, it will display the factorial of 0 is 1. Straight away it will display factorial of number 0 is 1. Then we have a else condition, means suppose the number is not less than 0, it is not equals to 0, then of course it is greater than 0. And if it is greater than 0, what we are doing is, in the print statement we are calling a function. You can see we are calling a function recur factorial by passing the value to the recur factorial. Now from this it will go to recur factorial function. Now let us look at what we have defined in the recur factorial a recursive function. So it will call recur factorial, and the value which we are passing from there, it will be stored in n. Here we are checking. So this is a stopping condition in the recursive function, and stopping condition is very, very important here. So if n is equals to 1, if the value of n is equals to 1, we are simply returning the value n to the calling program. From here directly it will go to the calling program if n is equals to 1. Otherwise, if n is not equals to 1, what we are doing here, it is important, we are simply saying n into whatever the value of n multiplied by, again we are calling the same function. Now you can see we are inside the body of recur factorial, and from inside the body of recur factorial we are again calling recur factorial, and this time we are passing a value 1 less than the value which we have received. So it is n minus 1. So if we have received an n value n, we are simply deducting 1 from it, and we are again calling the function, the same function, from that point. And that is the reason this is called as recursive function calling itself. From the same function we are again calling the same function. From recur factorial, from the body of recur factorial, we are again calling recur factorial, and that is why it is called as recursive function. And recursive function, you can see it creates a loop. So again it executes this way downwards, and if this is true, again it goes back to factorial. So this is how this continuously executes until this condition is true. So that is the reason this is the stopping condition which stops the recursive execution of a function. If this condition is not defined in a proper way, the loop may not terminate. It will simply go on calling recur factorial n number of times. Okay, so this is how this recursive factorial function works. Let us see by considering some value for calculating factorial. So consider the same thing, calculation has been demonstrated by using an image here. So let us consider now we are reading a number from a user. Okay, so let's say we are reading a number, input, enter a number. So user enters a number 5, we have considered, so that 5 will be stored in num. Then we are checking if the num, that is 5, is less than 0. If it is less than 0, it will display, sorry, but the value of num, it is not less than 0. This condition will become false. So it is greater than 0. So it will go for second condition, else if num is equals to 0, what is the value of num? It is 5, and that is not equals to 0. So even this condition is false. Then it goes to the else condition, and here we are calling recur factorial and we are passing number. So we have considered the value as 5. So from here we are calling this function recur factorial and we are passing value as 5. Okay, so n is equals to 5. So once we are in recur factorial, we are checking again if n is equals to 1. If you look at the value of n, it is 5, that is not equals to 1. So this condition will become false. As it is false, it goes to else part. In the else part, how we have calculated? Return to the calling program. What we have to return? N, that is 5 into recur factorial. We are again calling the function, and the new value which we are passing to recur factorial, it is n minus 1. That means 5 minus 1, that is 4. So from this point again it calls recur factorial and by passing the value 4. So again the code executes, it checks If 4 is equals to 1, no, it is false. If it is false, it will again calculate n into, now the new value of n was 4, so it will calculate 4 into again recur factorial by passing n minus 1. So next time it will pass, the value is 3, 4 minus 3. So from here again it will call recur factorial. Now the value which is passed, it is 3. Same way it goes on calling for values 2 and 1, and when it becomes 1, when we pass 1 here, so this condition will become true. If n is equals to 1, this will become true, and once this is true, it will return n. N is 1, so it will return value 1 to the calling program, the last calling program, and the function works in a reverse way when it reaches the ending condition. To understand this in a better way, we have a diagram here. Now look at the diagram. First time we have called the recursive factorial function by passing value 5. Then, as I have said, the condition not satisfies, it falls. It calls, it says return 5 into fact of 4. Again, it will go on calling 4 into fact of 3, then 3 into fact of 2, then 2 into fact of 1. So at the end we are calling factorial of 1. So factorial of 1 means n ka value we have 1, and when n is equals to 1, this condition satisfies. N is equals to 1, return 1. So at this point it returns 1 to the calling program. From here we have called fact of 1, so here it will return the value as 1. Then the equation will become 2 into 1. So 2 into 1 it is 2. So 2 into 1 is written back to the calling program. So we have called here fact of 2 from here. So this result 2 into 1, that is 2, you can see it here, 2 into 1, that is written to fact of 2, and it will calculate 3 into this factorial. So 3 into 2, that will become 6. So 6 is written here. So it will calculate 4 into 6, and that is written here. So 4 into 6, it is 24. So 24 will be written here. And lastly, it calculates 5 into 24. 5 into 24, it is 120, and that 120 is returned to the actual first call to the function which we have done from here. So here at the end the value which is returned, it is 120. So as the function it is called initially from print statement, it will simply print value 120. So that will be our factorial of 5. So when we call factorial function, it goes on calling the same function multiple number of times, and when it reaches the stopping condition, in the reverse way the values are returned back. The values are returned back by calculating the factorial. So this is how a factorial function works, the recursive factorial function works. There are other problems which can also be defined in a recursive way. You can define a Fibonacci program in a recursive way. So you just try it out to write a recursive function for calculating Fibonacci numbers, and also you can write tower of an problem in a recursive way. So try those functions to solve the problems in a recursive way. In today's session we will stop here. Thank you.